Thomas Frey has been featured in hundreds of articles for both national and international publications, including the New York Times, the Huffington Post, USA Today, US News and World Report, the Times of India, the Fütürist magazine, and several others. He currently writes the weekly Future Trend Report newsletter and a weekly column for FuturistSpeaker.com.
He is the author of Communicating with the Future, and today he will be sharing some of his keen insight into future generations and in the education world and beyond. Please join us in welcoming Mr. Thomas Frey as he takes us on an eye-opening journey through his own discoveries and predictions about the future of education.
All right, thank you very much. I am deeply honored to be here with you today. Let's have everybody just stand up just a couple of seconds. I know you were all just getting comfortable. All right, we're a very backward-looking society. We're backward-looking because it's just human nature. We've all personally experienced the past. When you look around us, we see evidence of the past everywhere around us. All information that we come into contact with is essentially history. So the past is very knowable, but we're going to be spending the rest of our lives in the future. So it's almost as if we're walking backwards into the future. My job as a futurist is to help turn people around and give them some idea of what the future might hold. And we're going to do some of that here today. One of the things we do is we take people on a journey into the future, and we do that through our visionarian process. So what do we know about the future? We know that the future is constantly unfolding. It's relentless. It's going to happen whether we want it to or not. It's one of nature's greatest forces. So the future is going to happen whether or not we agree to participate. You should try it sometime. Say, I'm not going to go into the future. Yeah, good luck on that. The future is in control. So if your next project is not aligned with the problems, needs, and desires of the future is going to kill it. Notice I said the problems, needs, and desires of the future, not of the present, not of the past, but of the future. So how do we align ourselves with what's happening in the future? The question we should be asking is, what does the future want? Now, we're going to come back to that question here in just a second, but let me first start off with a disclaimer here. I often get asked if I have a crystal ball. And yes, I do have a crystal ball. It was sitting around at home, and my wife told me, she says, why don't you just take this to the office? It's just collecting dust here in the house. So I put the crystal ball in my car, and I was driving to the office. I was no more than a few minutes down the road, and I looked over and I saw that the crystal ball had started a fire in the car next to me. The sun was shining in, and it's a giant lens, and so that started a fire there. Luckily, I was able to put it out, so it didn't cause any real serious damage. But just after that, I had a major revelation. Finally, I got a good reading from my crystal ball. The newspaper headlines the next day were going to say, "Futurist killed by his own crystal ball." and he didn't see it coming. So that's like the ultimate insult for a futurist. But that's my disclaimer. I certainly don't see everything. So when we go on to this question of what does the future want, let's change the question a little bit to how does the future get created? The future gets created in the minds of everybody around us. We're all participating in creating the future. People make decisions today based on their understanding of what the future holds. This is a real critical part. So I talk about the future creates the present. This is just the opposite of what most people think. Most people think that what we're doing here today is going to create the future. But from a little different perspective, these images that we have in our heads, these visions of the future, determine our actions today. So if we change people's visions of the future, we change how they're going to make decisions today. So this is important. I'm going to change your vision of the future here today. So you will leave here after all of these speakers today, and you're going to be making different decisions. That's important to understand. As my favorite physicist, Max Planck, likes to say, when you change the way you look at things, the things you look at change. All right, let's try to get your brains working here a little bit. Who in your mind is the world's most famous person? And we'll put some criteria on this. We'll make it in the non-religious sense. Who's the most famous person of all time? Since I run the Da Vinci Institute in Colorado, I happen to be partial to Leonardo da Vinci. Some people might say Da Vinci. Christopher Columbus, Isaac Newton, Einstein, Thomas Edison, Gandhi, Ataturk, maybe but the most famous person of all time, I think, is probably But after thinking about this question for a while, I came to the conclusion that the most famous person of all times probably is somebody that we don't know, or somebody who hasn't been born yet. Now this should be a real inspiring notion, because there's an opening. There's an opening for somebody to become the most famous person of all times. The next question you should be asking then is, if that's true, then what is the accomplishment that's made that person the most famous? Another way of asking that is, what are the big things that still need to be accomplished in the world? And as we look around, there are lots of big things that still need to be accomplished. I'm going to step you through a scenario here, and it's going to be taking place in the year 2018. It could be 2020 or 2025, but the idea is that the Norwegian Nobel Committee decides on a new process for selecting the winners of the Nobel Peace Prize. And so they have a peace mandate. They've got to promote peace around the world. So with the introduction of a new voting system, a secure voting system, they're inviting people around the world to participate in selecting the winner of the Nobel Peace Prize. So this is a global election. Their goal is to inspire peace around the world, and so they're going to do it through this process and promote peace along the way. So they start with a panel of 4 nominees. They select the initial 4 possibilities, and then they announce this 60 days before the election. It's a 24-hour election process, and votes can be cast through any electronic device. Now, this ties in nicely with their peace mandate. But they decide that they don't want people to just select the name on the ballot. They want them to know something about each of these candidates, because that's the way that they promote peace. So they actually pre-test each of the voters. And they do that by asking 2 questions about each of these candidates. Now, these aren't designed to mess people up or anything. They're just 2 rudimentary questions, and you get 4 attempts to get them right. In the end, after the 60-day process, the winner is announced. 740 million votes have been cast from people in 50 different countries, and the winner suddenly becomes the most famous person in the world. So does that sound like a reasonable scenario? Does that sound like something that could happen? I think possibly. So there's other real interesting applications for this idea of a global election process. What could you use it for? Maybe selecting like the Time Magazine Person of the Year, or the next site for the Olympics, or the next site for the World Cup. But there's also ways that you can do it wrong. Somebody's probably going to want to select a new world leader. Yeah, it's probably not going to go over so well. Voting on who owns the moon. Yeah, I don't think that'll go over so well either. But there's lots of kind of dicey issues as to which country owns a certain island, whether we should ban plastic bottles or something like that. But it begs this question, at what point does the number of votes constitute a new global mandate? At what point does the size and shape of this voting electorate then, and it gets to the idea of a higher authority. How do we make decisions? What's important and everything? In the world of education, who is our higher authority? Who do we go to decide how can we determine what things are the most relevant? What should we be teaching? So other possible applications for a global election, there's lots of different ideas that are coming about. But the last question I'm asking here is, will it create new industries? And I have to say, yes, I definitely think it's going to create quite a few new industries. So this is what I call a catalytic innovation, which is different than a disruptive innovation. Disruptive innovations actually disrupt existing industries. Catalytic innovations actually launch entire new industries. Some examples of this in the past have been electricity, automobiles, airplanes, telephones, photographs. Each of these has gone on to create entire huge industries. Now, when we start talking about new industries, each industry is a bell curve. It has a beginning, a middle, and an end. Yes, all industries end. Every industry that we have today will probably be gone 1,000 years from now. Will probably be replaced with something else. So the other interesting point is that most of the industries we have today, most of the big ones that are making most of the money, are in the second half of the bell curve. They're being forced in this position of doing more with less. So we're going to take this example here, this idea of peak steel. We hear a lot about peak oil, but that's a whole different topic. Peak steel is an interesting one. Projections are that the peak demand for steel is going to be reached somewhere around 2024. That's when we start developing composite materials that are going to make it so that the demand for steel itself is going to start slacking off. Now, before we reach the peak demand for that goods or service, whatever it happened to be in an industry, we reach the peak employment in that industry. The peak employment in the steel industry actually happened in around the 1980s. Now we have much more automated equipment. We're doing much more with less. And so at least in the United States, we're producing far more steel, but with roughly a third of the people that we had back in the 1980s. So this begs the question here, have we reached peak employment for education? And if not, when will we reach the peak demand for education-related services? I'll come back to this question in a little bit here. Now, as I go through this talk here, I'm going to step you through 5 different trends. The first one is that technology is changing the way we learn. That one seems very obvious and fundamental, but it's interesting to just point that out, that technology is changing the way we learn. Future industries will define the skills needed by the workforce of tomorrow, and future skills are driving future education. These future industries are going to demand future skills, and that's driving what we teach in education. The Quantified Self is creating a hyper-individualized talent marketplace, and I'll explain a little bit more what that is. And then teacherless forms of education are needed to meet the growing demand for education in the future. So we'll step through these each one at a time. The first one is technology is changing the way we learn. So 20 years ago, if you were handed a set of really tough questions, you would go into a library, you'd do a search, you'd use card catalogs, you would look at references, you would sort through and find those answers, and it could very easily take you 10 hours to find the answer you're looking for. That's what I call the 10-hour interface. Today, using a search engine and a screen and a keyboard, doing that same search, answering those same questions, could be done in roughly 10 minutes. So we've gone from 10 hours to 10 minutes. The next iteration of this will be the 10-second interface. Being able to somehow put a cap on that has electrodes on it and think our way to finding the answer. So if you think of people that could bring off the street and you set them down and ask them a question and they can answer any of those questions within 10 seconds, that's the 10-second interface. It's this whole science of neurotechnology. Now, if you're able to do that, then suddenly this idea of the who, the what, the when, the where goes away. Those are just factual pieces of information, and education then focuses on the how and the why. That eliminates lots of things. Now, I understand this is greatly oversimplifying things, but just doing this to illustrate a point. Today, technology is touching us in so many interesting ways. Every 60 seconds, a lot of things are happening. Every 60 seconds, there's over 2 million Google searches, 204 million emails sent, 1.87 million likes on Facebook, lots of Skype calls and tweets and apps downloaded, and there's 100 hours of new content loaded onto YouTube every 60 seconds. In 2009, two researchers, Roger Bond and James Short, looked at all of the information coming into our heads. These guys worked at the University of Southern California in San Diego. And they were doing this research just on Americans, but it's similar in people all over the world. So all of this information coming into our heads, and how do we quantify that? How do we rate it? So what they did is they translated it into the common denominator of words. How many words do we have coming into our heads on a daily basis? In the United States, in 2009, this was the number. It's 100,500 words per person on average coming into our heads. And that's a number that's going up 2.6% every year. We're consuming information 11.8 hours a day. And so naturally, you're wondering, where's all these words coming from? Turns out that 41% is coming from television, 27% coming from computers, 11% from radio, 9% from print media, and then other various sources for smaller amounts. So I looked at this and I decided to apply some math to this. So if you have a high-end information junkie, somebody who is actually spending lots of money subscribing to cable television, buying magazine subscriptions to newspapers, in the US equivalent of $10 a day, $300 a month, that puts you probably in the top 1% of all information junkies. That works out to $99.50 per million words. I thought, wow, that's kind of a bargain. I can buy 1 million words for less than $100. And then I thought, well, how much does that translate to in an Ivy League college? An Ivy League college, it works out to slightly more, $15,600 per million words. But the question I like to ask is this very simple question of how much are your words worth? We all make money communicating. And these words have value. So are your words worth more than other people's? There are some people who have some very powerful words to say. So I'll touch on 4 famous quotes that have been made, and then we'll look at them in a little more detail. Mark Andreessen is a famous venture capitalist who invented the browser. He says that software is eating the world. Vinod Khosla happens to be the most successful venture capitalist of all time. He says that big data will replace the need for 80% of all doctors. That's very significant. Clayton Christensen, a Harvard professor, very well-known author, he says that by 2019, half of all K through 12 classes will be taught online. And that Chris Anderson, the former managing editor of Wired magazine, he says that 3D printing is going to be bigger than the internet. These are powerful words. One of the predictions I made a couple years ago, actually I did it right here in Istanbul at the TEDx conference, is that by 2030, over 2 billion jobs are going to disappear. Now this isn't intended to be some doom or gloom statement. This is intended to be a wake-up call. That doesn't mean we're going to have 2 billion unemployed people in the world. It means that the jobs are going to transition through much quicker than ever in the past. So we need to create systems for creating new jobs. We're not there yet. I like to refer to this as the level problem. So when you think about the tool called the level that all the carpenters have used in the past, nowadays you can download the level on your smart device. And once you download that eliminates a piece of a job. Because suddenly you don't have to have anybody that's making the metal parts or making the glass bulbs. You don't have to have the people that are shipping and receiving these parts. You don't have to have the retailers that are carrying it in their store. And so downloading one of these mobile apps eliminates a piece of a job. And that's happening with every single app that we're downloading. So we're freeing up human capital. Now, just because there's not enough jobs doesn't mean that we're suddenly going to run out of work to do. I mean, that's a fairly ludicrous statement. So where are all of these next generation jobs coming from? We're going to look at some of these. So future industries are going to define the skills that will be needed by the workforce of the future. And I wrote a paper on 24 hot industries that are going to define the future. We're just going to look at a few of them here today. The first one is programming and app development. So when Mark Andreessen talks about software eating the world, that's really what's happening. We're actually creating a digital information layer over everything physical in the world. And a lot of that's happening in what's called the Internet of Things. Now, for those of you who don't understand what the Internet of Things is, this is something that Cisco defined. The origin of the Internet of Things happened around between 2008 and 2009. That's when the number of devices connected to the Internet started exceeding the number of people on Earth. So it was 6.8 billion people at that time. So we just started exceeding 6.8 billion devices connected to the Internet. Now the projections are that by 2020, we're going to have 50 billion things connected to the Internet. We're going to touch on some of these as we go along here. Now, in addition to the Internet of Things are the number of sensors that we're creating and putting all over the world. There was a conference held in October of last year by Fairchild Semiconductor, and they looked at what point do we reach 1 trillion sensors in the world. So they put together a roadmap, and they projected that by 2024, we're going to reach 1 trillion sensors in the world. And by 2036, we're going to have 100 trillion. Naturally, my question has always been, what can we do with 1 trillion sensors that we can't do with 10 billion? And then what are we going to use all these things for? But if you put that in perspective, the number of sensors that you have in a single finger on your hand probably is around 1 trillion. So we're just getting started. As a result of this, innovation is being parsed into far smaller pieces. That's enabling many more people to participate. We're creating all these tiny cottage industries of people making mobile apps and mobile devices that tie into this. And it's much easier to get started. The barrier to entry continues to drop. So as this is happening, we're creating a variety of smart devices, smart homes, smart cars, smart clothing, smart furniture, smart shoes. And yes, as soon as we make an interface device for our shoes, we're going to start creating mobile apps for our shoes. I want the one that makes me run faster. But we're in this age of constant communication. We have people that are connected, jacked in all the time. It's gotten to the point where we've reached this device addiction. And a recent study showed that 1 out of 3 people would rather give up sex than their phone. So if you look at the people sitting next to you, if it's not them, but we're actually in this age of hyper-awareness, and this doesn't get talked about very much, that the internet is enabling us to be aware of things happening all over the world all the time. So if somebody releases a new report in Mexico City, in Moscow, or Tokyo, people all over the world will know about it 10 minutes later. That's really important. So we're speeding up the flow of information. And these new devices that we're coming out with, this is Google Glass, this is Sergey Brin demonstrating Google Glass. There's several other companies that have competitive devices so these wearable technologies are going to be very popular in the very near future. But it doesn't stop there. Yes, I know if you're looking across the table at your boyfriend or girlfriend and you see these in their eyes, it's a little different experience. But these are smart contacts. There's prototypes out there, people are working on. This is very sophisticated technology with lots of information coming and going, as you can see right through it. So to give you a demonstration of how this works, if you're looking at a plate of food, like on the top left corner up there, you can have a visual overlay and find out how many calories are in the food, the nutritional value. You can even get a weather report. Over the bottom corner here is a little coupon. That's just fundamentally wrong. There should not be any coupons in your eye. So how will changing the speed and flow of information affect how we present education? It's a good question to be asking. Industry number 2 is 3D printing. 3D printing is going off in a million different directions, but I'll start with, this is the statue of David. It's a very famous statue carved by Michelangelo. It took him 4 years to carve the statue out of a solid block of marble. Today, we could use 3D printers and recreate this in composite materials that will last just as long in somewhere between 1 or 2 days. So going from 4 years to 1 or 2 days. This is the guy that's responsible for much of the 3D printing industry, Charles Hull. His innovations happened in the mid-1980s, but it's taken off in so many different ways. Right now, we're able to print in plastics and ceramics and concrete, metals, food, biological structures, liquids. This is an interesting device that was introduced at the Consumer Electronics Show in January. It's a combination 3D printer, scanner, and fax machine. So you can put an object in there, you can scan it, you can fax it to somebody else, and they can print it out on their end. And so if you want to send somebody something cool for their birthday, you could put it in there. I don't know what that would be, but put it in there and send it to them. I mean, how cool is that? This is the first 3D printed bicycle. There's always this race to be first. This is the very first one. It's not a very good bicycle, but it works. So it's the first one. This is the first car, 3D printed car. Again, not a very good one, but it's the first one. Sometime in the very near future, when you go buy clothing, the first thing you're going to do is step into a body scan. It'll scan all the dimensions in your body, And then you can walk around, pick out what fashions you like, what colors, what styles, and they will print it out right there as you're waiting. This is a picture of my wife at the Consumer Electronics Show. She's actually standing in front of a smart mirror, and she's trying on different clothing, and she swipes the different dresses onto her body. And so you can try on a lot more clothing that way. So this is what the vision is for 3D printed clothing. Are we going to have these in schools in the future? Incidentally, this is a lot like the book publishing industry because these designs get published. These designs for clothing, for buildings, for products, they all get published, and then we work with those. They're information products. So this is what 3D printed clothing looks like. We can print things that we can't possibly make with today's normal fabric. Some of these things stick out in interesting ways. I refer to this lady as Porcupine Woman. It's hard to get close to her. But it's not just clothing, it's also shoes. We can print our shoes as well. And the interesting part is since you're scanning all of these dimensions, everything fits perfectly the first time. So your shoes will fit perfectly. The clothing is actually pretty coarse material, but it's going to get much better in the future. So you can see what some of these shoe printers look like here. And we can also print jewelry. I mean, how cool is that? Now, I'm going to show you this other direction that 3D printing is going in. It's this idea of being able to print buildings. So there's a group at the University of Southern California in San Diego, working on a concrete printer. And they refer to this under the term contour crafting. So they don't necessarily refer to it as 3D printing. They're starting off with printing in ceramics here. In just a bit, it'll switch to printing with concrete. Now, the goal here is to be able to print an entire building, an entire house. And the guys working on this, okay, here's the 3D printed concrete. They're printing a wall right now. If you think of a concrete pumper that's pumping material into this thing, and it's just putting one layer upon another layer upon another layer. They're predicting that they'll be able to print an entire house in less than a day. Just a few hours, in fact. So you can see how all of that comes together here. Looks kind of cool, doesn't it? So here's the deal. Sometime in the future, you get tired of your house, you can just grind it up and reprint it. And you're not just printing the walls, you can reprint the furniture, you can reprint the cabinets and the fixtures and all that. Yeah, and two-story house. And then suddenly there's going to be this competition as to who can be first to build the tallest building with the 3D printer, who can build the first hospital or the first school. NASA's looking at how do we build a base on the moon with this thing. Every flat wall then suddenly becomes an artistic centerpiece. We no longer need flat walls. We can be very creative. Architects are going to have a heyday with this as we can build freeform structures and designs that are impossible to create with today's construction techniques. And incidentally, we can print with concrete for a while, and then with glass for a while, and then with steel, and then back to concrete again. And so we're going to be able to create buildings that are inconceivable by the standards today. This is actually a Dutch group that's working on this. It's slated to be printed later this year. That's kind of a Mobius strip design. And so they're in this race to be first. There's a group in London that's building, this is kind of a quirky thing, the first printed house. It looks like some alien structure. Not sure I'd want to live in this thing. But it's the race to be first, and so we're going to see a lot of crazy stuff coming out of this. This is 3D printed skin for burn victims. This guy's printing a vein for surgery. Lee Cronin from the University of Glasgow in Scotland thinks that we can print all of our pharmaceutical drugs so that we can replace entire drugstores with a machine. You just put in your prescription and you get out all the drugs that you need. And this is Craig Ventnor. He says that we are able to print antibodies and new life forms. And the Chinese have already printed new kidneys. So printing new organs is happening very quickly. And if I haven't gotten weird enough yet, 3D food printers are right on the horizon. So imagine sometime in the very near future, you send your spouse out to the store to get a kiwi cartridge and an eggplant cartridge because you're going to print dinner tonight. So these are what 3D food printers are looking like. NASA's actually very interested in, they ran a competition on the first pizza printer. This is what came out of that. They're looking at how do we create a variety of food when we send a colony to Mars. And so they're playing around with different ideas. So this is a 3D printer that's printing in sugar. A lot of the food printers right now are working with confectionery creams and chocolates and things like that. One of the machines I've seen actually will scan your face and print your face in chocolate. Not that I'm really interested in eating somebody's face, but. So is this a plate of food that you would eat? Maybe, maybe not. I always like to use this example here, all the apples that fall off of an apple tree. Most of them are damaged and bruised, and because of that, they go to waste. But what if you could take that same apple stock and reprint it into a perfect apple? Not only is it a perfect apple, but you could also eat the stem and the core and the leaf because it's all printed out of the same material. Only you happen to like almond flavoring, so we can add that in. So we have almond flavored apples, but you need more vitamin D. Well, we can do that as well, add vitamin D into it. And every Wednesday, you happen to like blue apples, so we can create blue apples. So would you buy a product if it was naturally grown, completely organic, printed food? Does that sound kind of crazy? Sometime in the very near future, we will have companies that first print the can, and then they'll print the soup that goes in it. Or they'll print the bottle, and then they'll print the wine that goes in it. Is that a little bizarre? Maybe. As Chris Anderson says, 3D printing is going to be bigger than the internet. He actually left his job at Wired Magazine because he believes so strongly in this. He says the physical world is 5 to 6 times larger than the digital world, and so he's putting his money where his mouth is. The third industry is atmospheric water harvesters. There's a lot of work going on in this area of being able to suck moisture out of the air. These are fog screens here. MIT's got a research project in Peru. You're able to, depending on how much humidity there is, you can suck a lot of moisture out of the air. So rather than drilling wells and hauling water up, it's a very laborious process. You can put these up and it just drains into whatever canisters you have. This is Eoli Water. It's a French company that they're using in Abu Dhabi right now to suck moisture out of the air. They can get up to a little over 500 liters a day through one of these little windmills. Edward Liniger created this company called Airdrop Systems, which is a solar powered unit that can suck moisture out of the air and then irrigate plants. And in this industry, the holy grail is the idea of the self-filling water bottle, so that you can have a water bottle that you take with you all the time and it just constantly fills itself. How cool is that, huh? Commercial drones and robots, we're seeing lots of activity in this space. The number of robots at Consumer Electronics Show this year was a 10-fold increase over last year. This is a French company that's actually figured out how to deliver newspapers with a drone. This one's the burrito bomber. So you order a burrito and it will fly over and it'll drop it out with a little parachute and it falls into your waiting arms. The pizza companies don't want to get left out delivering pizzas with drones. A lot of the drones are getting used for the agriculture world. We're coming up with all kinds of interesting things. China has actually figured out a way to use drones to stop pollution. But the farmers actually are able to fly these things over, and they can scan a field, and they can check for how many insects or the disease or the water, the moisture levels, fertilizer levels in different parts of the field. And you can have the quadrocopter version or the fixed wing or helicopters. And we're also using these for emergency rescue. So if somebody gets caught in an avalanche or gets caught into a fire or something, we can send these out and not put people in harm's way. News organizations are going to use them to get the latest news very quickly. Whenever something happens in a city, the city's first response will be to send up a drone to get eyes on it. And so we will have these things flying around all over the place. What's interesting with forest fires, we have the ability to spot forest fires when they're very small. It's very easy to put out a forest fire if it's just a small area that's burning. But once it gets to be a big area, it's enormously difficult. So we have the ability to use drones to scan the forests and to virtually eliminate all the forest fires altogether. So rather than to wait when they get totally out of control, we can send in the fire extinguisher drones to put them out right away. And how cool is that? Driverless cars. Boy, I want one of these. The guys from Google have been pushing the envelope on this, Larry Page and Sergey Brin. This is actually the first one that's available on the market. Excuse me. This is $150,000, and it's one that's good for using in like airports or shopping malls or theme parks or things like that. Only goes 12 miles an hour, roughly 8 kilometers an hour. Virtually every major automobile company has a driverless division, and they're working on this. They had several models at the Consumer Electronics Show. They were actually giving rides in these things. But if you think about sometime in the future, you don't have your own car anymore. You just step out in front of the house and you use your smart device. You punch in, you want to go to school, you want to go shopping, you want to go to the office. And a driverless car will come and pick you up. And it'll take you there and drop you off and pick up somebody from there and drop them off. And these things will be in circulation all the time. And so the car company is going to shift from the driver experience to the rider experience because people are no longer going to be driving cars. And car companies will shift because most people aren't going to own their own cars in the future. So they'll shift from trying to make money by the number of units they sell to by charging per mile, per kilometer, for transportation. What this does is it eliminates the human variable. And so it eliminates all the accidents, it eliminates all the injuries that go along with that, and it opens up the doors for people who currently can't drive, either because they're getting older, and for those of us that are getting older, we're going to demand these type of vehicles in the future. So this is what an intersection will look like in the driverless car world. Yeah, kind of like today, isn't it? All right, the sharing economy. So the sharing economy, libraries were the original form of the sharing economy. This is something that appeals to the young people today much more than the older generations. Older people like me are just kind of catching on to it. But the CEO of Airbnb, who's really taking on the hotel industry in an interesting way, the CEO says that there are 80 million power drills in America that are used an average of 13 minutes. And then he asks the question, does everybody really need to own their own drill? So what this does is it transitions us from the just-in-case world to the just-in-time world. So we have a toolbox in our garage just in case we need to fix something. We have a car in our garage just in case we need to go somewhere. We have appliances in our kitchen just in case we want to make some dinner. But if you have access to those things whenever you need them, but you don't have to own them, that changes the equation. Zipcar, as an example, is being placed all over the world. It's in 27 different countries. One Zipcar replaces 15 private cars. Uber is one that utilizes people who already have their own car and works with them, and they can give other people rides. And so lots of ride sharing there. Airbnb, already 10 million guest stays. This is a company that's worth well over $1 billion now. It's in the sharing industry. For people who are leaving and they want to make sure their dog is taken care of, this is a site that matches up people willing to take care of your pet while you're gone. TaskRabbit, if you have something that you want done, is the place to find somebody that can do those tasks for you. Same with Zarly, people that have unusual skills, unusual tasks. And the TED Talks, one of the original sharing sites. They're sharing information to people all over the world. The last one I'll talk about here this morning is the super high-speed transportation. There's quite an interesting debate going on between Elon Musk and Daryl Oster. Elon Musk became concerned when they were going to build a high-speed rail system between Los Angeles and San Francisco, and he proposed something called the Hyperloop. Daryl Oster on the right here has been working on a similar concept. This is actually a form of tube transportation. So this is the Hyperloop vision here of sending cars that are riding on a cushion of air through this tube that doesn't have hardly any air in it. Daryl Oster believes that you can evacuate all the air out totally and have these capsules riding on maglev rails, and actually there's no friction whatsoever. So it's like space travel on Earth. So people will be able to travel roughly 6,000 kilometers an hour. So with this type of system, you could travel. I have LA to Sydney here, but you could travel from Istanbul to Los Angeles in 2 hours. So that gives you an idea of how fast this is. Once they're able to prove this out, this has, every country in the world would suddenly want to get tied into this. This has the potential to be the new 5th form of transportation. In addition to cars and trains and buses, becomes the 5th form of transportation, and has potential to become the largest infrastructure project in the entire world, costing trillions of dollars, but it's going to pay for itself, and employing hundreds of millions of people over the next 50 years. That's what I find exciting about it. So these are the 7 hot industries: programming, 3D printing, atmospheric water harvesters, commercial drones, driverless cars, and so we'll go on to our trends here again. The third trend is future skills are driving future education. So what will the workforce of the future look like, and how do we go about creating it? Obviously, everybody's going to have white heads. So we've been exploring this idea about micro colleges at the Da Vinci Institute. I made the prediction that by 2030, well, first of all, the average worker is going to reboot their career 6 times by 2030. But I predicted that by 2030, half of all traditional colleges are going to disappear. And there's a number of factors in place, because we can do it far cheaper and more efficiently online. It doesn't mean all of them are going to go away, but a lot of them will. And there's much less need to have big fancy buildings. We can transfer knowledge more efficiently in other ways. So micro colleges are an immersive form of post-secondary education in short periods of time. So somebody who's going to reboot their skills and change career paths, they want to do it in the least amount of time. Colleges tend to be a very poor fit for that. So people would rather do it in 2 or 3 months rather than 2 or 4 years. And colleges are not equipped well to do that. So we have our own immersive form of education at the Da Vinci Institute, where we're teaching classes on computer programming. This is all part of our Da Vinci Coders program. The demand for programmers is just going through the roof. By 2020, half of all the programming jobs are going to go unfilled just because there's not enough talent. These guys make a lot of money too. So other forms of micro colleges that we could create, everything from a dog breeder university to somebody that becomes a brewmaster to brew their own beer, pilot drones or aquaponics farmers, competition schools, things like that. Lots of opportunity. At the Da Vinci Institute, we offer just a certificate. You complete this, you get a certificate. We're telling people that if they spend roughly 1,000 hours and gain 1,000 hours of proficiency, they can get a foothold into the programming arena. That tends to work pretty well. I'm going to touch on a couple other ideas here in an interesting way. We've been playing around with some other ideas. One of them is this idea of micro credits. So because of all of the learning that we have, we're consuming information at 11.8 hours a day. A lot of it's not that valuable, but some of it is. So if we could get credits for going to a movie and you take a test, or read a book and take a test, this idea that 100 micro credits would equal 1 traditional college credit, that seems to resonate well with a lot of people that we talk to. The other idea we've been playing around with is this idea of somehow creating a competition. If we take a stable piece of information, virtually every college in the world teaches economics. If you just take Econ 101 and you hand off all that information to a movie producer will figure out how to make it much more entertaining and more interesting and compress it down, and they come up with a vastly different way of producing that. If you handed it off to a game developer, again, they would figure out how to make it much more entertaining, compress it down, gamify a lot of the aspects of economics, or the same as if you handed it off to an app developer or a virtual reality person. So the thinking was, is if we ran an annual competition on Econ 101, who could do the most interesting thing, had some interesting prizes, that if we did that 10 years in a row, that after 10 years, the format for how we would present that education would look so vastly different than anything we have today that it would be quite revolutionary. As Mark Twain says, that a man who carries a cat by the tail learns something he can learn in no other way. Isn't that the truth? All right, the quantified self. The quantified self, I think, is very interesting. This is a term that was actually developed by Kevin Kelly out in the Bay Area. It's a way of actually measuring all of the things about our human body. Everything from the quality of the air that we're breathing, the quality of the water that we're drinking, and all the inputs and outputs, so the chemical composition of the sweat on your body. So the quantified self also will be measuring all of the information you're taking in and what skills you're developing along the way. So we're doing that through all of these wearable technologies that we're able to actually measure what's going on inside our body. So these smart body monitors, wristbands and headbands, and then we've come up with actually some smart skin devices, which I find rather interesting. You can just attach them to your skin, and they're very sophisticated devices, lots of information coming and going. And the next generation of them will actually be printed on our skin. And for those of you who don't like tattoos on your skin, the next generation tattoos have a turn on, turn off feature. So you can turn it off when you don't want to. Is that a good idea? So if you think in terms of monitoring like 947 different categories of skills and knowledge, attributes and characteristics, that's kind of what we're talking about here. And when Vinod Khosla talks about big data, eliminating the need for 80% of all doctors, you think of doctors that are going to school most of their life so they can make great decisions. Well, actually, machines and sensors can actually make those decisions far more efficiently. But let's put this in perspective, though. It was still in the 1970s when we had as many as 5 people in the cockpit of an airplane. And we've eliminated 3 of them, and they're actually taking a serious look at eliminating the co-pilot, too. So that would be eliminating 80% of the people in the cockpit. If we eliminated 80% of all doctors, it's not going to happen instantly. So the quantified self is a way of measuring everything that's going in and out of our heads, as well as in and out of our bodies. So imagine connecting to a scanner for a quantified self-assessment. One scan would instantly tell people what jobs they're currently qualified for, and then what deficiencies they have for performing other jobs. So if you want to move into another area, it's not going to tell you that you need to get another 4-year college degree. It's going to tell you you need to take this class, you need to read this book, you need to watch this video, or something like that. Teacherless forms of education are needed to meet education's growing demand. Now, the demand for education is going to continue to go up. We're not going to need less education in the future, but we need more efficient education. So a couple of years ago, I was here in Istanbul, and I was talking about our need for teacherless education. And afterwards, one of the executives from Google came up to me, who happened to be sitting in the audience. He says that idea of teacherless education really resonates with us, because at Google we're very interested in educating Africa, and teachers don't want to go there. And that's very much true. There's lots of places in the world that teachers don't want to go. In the big cities, the great places around the world, there's too many teachers that want to live there. Lots of places where they don't want to move to. So we have a big teacher shortage in the world, 18 million globally by one count. So 23% of all children growing up today do not attend any school at all. So there's a huge opportunity there if we can somehow get the information to them without the need to go through a teacher. So when Clayton Christensen talks about by 2019, half of all K through 12 classes will be taught online, what he's actually referring to is this type of situation where half of the classes, students will be jacked in, they'll be taking classes at their own speed, the things that interest them, and they'll move along at something that works well with their personality. But if we continue to have to insert a teacher between us and everything we're going to have to learn in the future, we can't possibly stay competitive. We need to know too many things in the future, so this on-demand education is far more important. It's going to get even more so in the future. As Albert Einstein says, education is a progressive realization of our own ignorance. I think that makes sense. So when I talked about by 2 billion jobs going away by 2030, McKinsey and Company did a study a year ago that said that for every job eliminated by the internet, another 2.6 new jobs were created in the online, in the startup world. So we're not going to eliminate all of those jobs. Some of the predictions, I'll just go through these. The Internet of Things will virtually eliminate theft because we'll know where everything's at. Big data will destroy the stock market, causing a new breed of capital markets to emerge. And driverless cars will change transportation as dramatically as the invention of the automobile itself. So by 2030, the average person will own printed clothing, will live in a printed house, have packages delivered by drones, will own more than one robot, will work out of a business colony, will share most of what they own, will frequently use a driverless car, and will be three times more educated than the average person today. But we're entering a period of unprecedented opportunity. So why is this so important? Humanity is going to change more in the next 20 years than in all human history. Risk factors are going to increase exponentially. And our children's children who haven't even been born yet are counting on you. As Steve Jobs says, right now is one of those moments when you are influencing the future. But sometimes our best efforts look a lot like this. Yeah, pretty much like that. Thomas Edison says opportunity is missed by most people because it's dressed in overalls and looks like work. Isn't that the truth? So for more information about what we do at the Da Vinci Institute, about our Visionarium process, you can sign up for a free newsletter. We'd love to send you some information. I'll be signing my books a little bit. I want to thank you all for having me here today. Thank you very much.